In our last video, we talked about how to solve a quadratic equation using the zero product property. Today we're going to learn what to do when you can't easily write your quadratic as a zero product. So in other words, if you can't factor, here's what you do. For starters, we're going to start with a really easy one. If you have x squared equals 16, meaning you have the x squared already by itself, the way you get rid of the square is by doing its opposite. So we would take the square root of both sides. But there's a catch to this. The square root of x squared is not just x. The square root of x squared, as we learned last unit, is the absolute value of x. And if we connect that to what we learned at the beginning of the year with absolute value equations, to solve absolute value of x equals 4, we know to separate that into two different equations. And so in the end, what we end up with is two possibilities that x could be either the positive or the negative version of the square root of 16. And what we're going to do, as we solve equations like this all the time starting from now, is we're not going to do all of this middle stuff in here. We're kind of going to skip that. It's just you have to know that when you take the square root of both sides, you have to know to jump down and call it the plus or minus square root. So that's going to be the important takeaway from that. Okay, if we look at the next equation, x squared plus 2x equals 16, why can't we do the same thing? Why can't I just take the square root of both sides here? Well, the reason is that the x squared is not isolated. And just like the absolute value equations, just like the square root equations, we know if you want to get rid of something, you've got to isolate it first. And you can say, all right, well, why don't I just isolate the perfect square and then take the square root of both sides? Well, the problem with that is, sure, I'd get my x by itself with the plus or minus, but having 16 minus 2x, that doesn't work. I can't have an x in a solution for x. That doesn't work. So we need another strategy. The strategy is to get that x squared plus 2x to be a perfect square. So first, though, let me actually say step one is to isolate not just the x squared, but the x squared plus bx. That's what we have started with in this problem. X squared plus 2x equals 16. Step two is to make that x squared plus 2x be a perfect square. The name is, the kind of official name of that step is called completing the square. The way we do that is by adding something to both sides. We're going to add, and this is going to look a little strange at first until we explain it, but you're going to add b over 2 squared to both sides. Well, this b is 2, so I'm going to add 2 over 2 squared. And usually you'll be able to do it in your head. If you need to write it down on the side, that's fine. 2 over 2 is 1, and 1 squared is 1. So I'm going to add 1 to both sides to get x squared plus 2x plus 1 equals 17. The reason why we do that, what's so special about x squared plus 2x plus 1, so special about adding that b over 2 squared, is it will always make a perfect square when we're done. Meaning, if I were to factor the x squared plus 2x plus 1, it will be something squared. In this case, it's x plus 1 squared. And that's my next step. Factor the perfect square. The reason why this works, the reason why adding that b over 2 squared makes a perfect square, is because if I ever take any number, I'm just going to call it m, x plus m, and square it. When I FOIL that out, because remember x plus m squared is x plus m times x plus n, and when I FOIL that out, I get x squared plus xm plus another xm plus m squared. And when I put them together, x squared plus 2mx plus m squared. And the key here, the connection that you need to make, is when you start with the quadratic trinomial like this, if it's a perfect square, the term in the perfect square, that m, is always, always, always going to be 1/2 of that b, that middle coefficient. Always. So that's why we do b over 2. And then the thing that's being added at the end, that we're putting here, that plus 1, that is always the square of that thing that's in the parentheses, which we just said is b over 2. So what I do is we take b over 2 squared, and that's what we need to add in to complete the square. That's why it works, though to be honest, it's not that important that you remember exactly why it works. What you do have to remember in this case, and I don't usually say that, but in this case, it's kind of important. Just remember to add b over 2 squared to both sides, and that will make a perfect square. And once we have made the perfect square, we can then get rid of the perfect square with the square root. So when we take the square root of both sides, that leaves us with x plus 1, because it's the square root of a perfect square, equals the square root of 17, which, first off, I cannot simplify in this case. Second, I've got to remember the plus or minus. So make sure you make a note to that, to remember the plus or minus. And then the last thing to do here, since I'm trying to get x by itself, is solve for x, which will normally be a very simple step of just getting rid of whatever that other number is. I'm going to subtract 1 on both sides. So x equals, the way we write this is -1 plus or minus the square root of 17. And what that means to us is that the two solutions are -1 plus root 17 and -1 minus root 17. So if we take a look at this here, I'm going to graph x squared plus 2x minus 16, and we're going to look for the zeros. I can see them just by clicking. They're these ugly, horrible decimals. What that means to me, or what my solution of -1 plus or minus the square root of 17 means that my two answers are -1 plus root 17, that's the 3.123, and -1 minus root 17, that's the -5.123. So you can see how these two numbers are the numbers at my x-intercepts. It takes a little bit of getting used to, but you'll pretty soon be able to see -1 plus or minus square root of 17. And instead of thinking of it as like this weird combination of a bunch of things that don't make sense, you'll start being able to see that as numbers. We can do one example together. Let's look at number 4 here. K squared plus 10 equals 6k. First of all, you got to remember, I don't want the 6k on that side. I want the 6k to be together with the k squared. So I'll need to subtract 6k. And I don't want the 10 there. I want the 10 on the other side because I want to get my k squared minus 6k alone. And then we need to figure out what we're going to add to both sides. That's the b over 2 squared. That's -3 squared is 9, so I'm going to add 9 to both sides. And so we know that this is a perfect square, x minus 3 squared. By the way, it's worth pointing out that this number, this b over 2, is always the same number that's in your perfect square. They're always, always, always the same. Equals -10 plus 9 is -1. And you might be sensing a problem coming on. If I take the square root of both sides here, I'm trying to take the square root of -1, which we know is a slight problem. But it's a solvable slight problem. We've said before, you can't take the square root of a negative number, but then we learned, well, you can, it's just what we call an imaginary number. So don't forget the plus or minus. And that square root of negative 1, we'll just call it I. And that's totally fine to have I in your answer. We're going to add 3 to both sides. And your final answer is 3 plus or minus I. And you might be asking, wait, what does that mean that x is an imaginary number? Well, what it means is that if we were to look at the graph, and I know this is a different parabola, but it has the same result. If we were to look at a graph of a parabola that doesn't have an x-intercept, that means the roots must be imaginary. If you were to solve this one, you would get I in your answer. We can take a quick look at it. X squared plus 4x equals negative 11. Pause the video and see if you can finish this on your own, and then just look back and check. Add 4 to both sides. Factor. Remember, we already know it's going to be a perfect square. And then we can take the square root of both sides, remembering the plus or minus. And then if we subtract 2 from both sides, negative 2 plus or minus, I'm going to pull out the I, and that's your answer.